Hi everyone, it's Ms Costa here, and in this video we're going to go through the Edexcel Foundation June 2018 paper 2. So to begin with, we're being asked to turn a fraction into a percentage. Now when we've got fractions, it's helpful to know that this line over here, it means divide. So either you can type into your calculator 4/50 as a fraction, or you can just type in 4 divided by 50. You'll end up with a simplified fraction, and then you press format. So format and then down to decimal, unless you're lucky and you have the old calculators, in which case you press SD, and that turns it into a decimal for you, which is 0.08. So to turn a fraction into a decimal, we just divide, and then a decimal to a percentage, we just multiply by 100. So 0.08 times by 100 is 8. So then 4/50 as a percentage is 8%. Another way you could have done this, if this was the non-calculator paper, is when you've got something and you're trying to express it as a percentage, you know that that means you want to get it as a fraction out of 100. So you could have used equivalent fractions and recognized that 50 times 2 is 100. So if you did 4 times 2, that would give you 8/100, and 8 divided by 100 is 8%. Okay, next we've got rounding. So when we're rounding, what we're looking for is, it's asking us to round to 1 decimal place. So 1 decimal place means I'm interested in the first decimal point, the first digit after the decimal point, which in this case is 5. So that's what I'm going to circle. I'm going to look at the digit next to it to its right, and if it's more than 5, so if it's 5 or more, I round up. If it's 4 or less, I round the number down. So I'm essentially trying to decide, is this number closer to 1.5 or 1.6? And in this case, the number next to it is 9, so I add 1 to my circle digit, and that becomes 1.6, because essentially it's telling me it's closer to 1.6 than it is 1.5. Then I need to work out the value of 3 to the power 5. So because this is a calculator paper, you need to know how to use a calculator. So the power button is over here, so it will look like that one there. You press 3, use the arrow, and then use that to write in 3 to the power 5, which tells you 243. If you didn't know, or you don't feel confident with your calculator, then when we've got indices, all this little power here means is how many times 3 is being multiplied by itself. So another way you could have done this is done 3 times 3 times 3 times 3 times 3, because it means 3 to the power 5. 3 is being multiplied by itself 5 times, and you would end up with 243 as well. Next, we're told write down a 6-digit number that has 4 as its thousands digit, and you can only use the digit 4 once. So we know we've got 1, 2, 3, 4, 5, 6-digit number, and this is going to be my ones column or units. This is my tens, this would be my hundreds, and this would be my thousands digit. So I'm being told that I need to use the number 4 as its thousands digit, so I put 4 in this place value, and then it literally doesn't matter what you do, as long as your first digit is more than 0. Otherwise, if you put 004789, then that number is just 4,789, because a 0, it doesn't have any place value before the number. So as long as you put anything like 1, it doesn't matter what the number is, as long as 4 is in the thousands column. Okay, so now I need to change 35 centimeters to millimeters, so it's helpful to write out my conversions. So I know that 1 centimeter is 10 millimeters, and this is just a fact that I need to memorize. And so if I'm trying to turn centimeters to millimeters, I know that each millimeter is 10 lots of 1 centimeter. So 1 centimeter, to turn it into millimeters, I times it by 10. So in this case, to go from centimeters to millimeters, I times by 10. So 35 times by 10 is going to give me 350 millimeters. Next, I need to change 7,700 milliliters to liters. So the fact I need to know is that 1 liter is 1,000 milliliters, and I'm changing milliliters to liters. So to get from milliliters to liters, what do I divide 1,000 by to get to 1? I divide by 1,000. So to turn milliliters to liters, I divide by 1,000, and 7,700 divided by 1,000 is going to give me 7.7 litres. The last one is I need to change 0.32 kilograms to grams. So once again, start with your fact that you know. 1 kilogram is 1,000 grams. And I'm trying to go from kilograms to grams. So to get from kilograms to grams, what do? I multiply by 1,000. So therefore I'm going to do 0.32 times by 1,000. And you can type that into your calculator because it's a calculator paper, which would give you 320. So the best way to do these is always write your fact that you know, or you should know, all your metric conversions. These are things that you're expected to know. And from there, decide whether you're multiplying or dividing. Next, I'm told that Margaret is thinking of a number. She says, my number is odd. So I know that it has to be an odd number. It's a factor of 36 and a multiple of 3. There are 2 possible numbers she could be thinking of, and I need to write down these numbers. So I could start by writing out all of the odd numbers under 36, but it would be a lot quicker if I started by writing out what the factors of 36 are, as that's going to narrow my numbers down. So to work out what factors of a number are, you think of 2 numbers that multiply to make that number. And normally they come in factor pairs. So it's easiest to always start with 1. So 1 times by 36 makes 36. Then try 2. 2 times by 18. Then try 3. 3 times by 12. And because this is a calculator paper, you can literally just type these into your calculators if your mental maths isn't that great. Then we try 4. And 4 times by 9 is going to give me 36. Then we try 5, and 5 doesn't work. You should know that because anything, a multiple of 5 is going to have to end in 0, 5. But if not, you try it in your calculator. So you do 36 divided by 5, and you see that it gives you a decimal. Factors have to be whole numbers, so therefore 5 doesn't work. So we try 6, and then I get 6 times 6. Now, if you're doing it in ascending order, so you're trying the numbers 1, 2, 3, 4 going up, whenever you end up with a number on the left side that is the same as the number on this side, you know you're done. Because if I then tried to do 7 wouldn't work. 8, hold on. 8 should work. 36 divided by 8. No, 8 doesn't work. Having a mind blank. So 8 doesn't work. If you tried 9, you know that you'd get back to 9 times 4. So you're repeating yourself. So that's why you know that you've finished with all of your factors. So I know that Mary, or Margaret rather, the number that she's thinking of has to be either 1, 2, 3, 4, 6, 9, 12, 18, or 36, because these are the factors of 36. Now, she also says that it has to be a multiple of 3. So what we can do is we cross out any number that isn't a multiple of 3. So you're just left with, I crossed out 6. 6 is a multiple of 3. So 3, 6, 9, 12, 15, 18, and 36. They're all multiples of 3. And the last thing is her number is odd. So I cross out any numbers that are not odd. So any even numbers I cross out. And therefore I'm left with 2 numbers. So Margaret is thinking of 3 or 9. Okay, next I've got a combinations question. So the really important thing to do here is to pick one thing. So in this case, we're talking about people. So if we pick Mohsin, and if he comes in first place, then Yusuf could come in second, or he could come in third place. So start with Mohsin, and then I'm going to write Yusuf and Luke, or Mohsen could come in first and Luke could come in second. So then Yusuf would come third. So they're the only possible combinations. If Mohsen comes first, the other two can either come second or third. Then I'm going to try the second person. So if Yusuf comes first, Mohsen could come second, and therefore Luke would come third. Or there's the option that Luke comes second and Mohsen comes third. So you're essentially trying each person and then eliminating all of your options, and it's the best way to do it this way rather than just randomly coming up with combinations. And then lastly, if Luke goes first, then Mohsen might come second, and therefore Yusuf would be third. Or alternatively, Luke could come first, Yusuf second, and Mohsen last. So when you're trying to list things like this, which are the possible outcomes of a game, you just want to make sure you've extinguished all your options one person by person. So all of the options for Mohsen coming first, then all of the options for Yusuf, and then finally all of the options for Luke. Okay, now we've got a direct proportion question. So there's a few ways that you can do this. If there was a non-calculator paper question, I would probably do this differently. But because it's a calculator paper, the quickest way is probably to work out the value of 1 unit. So I'm told that Neil buys 30 pens, 30 pencils, 30 rulers, and 30 pencil cases. So a pen is 6 for 82 pence. So if I worked out, I know that 6 pens are 82 pence. And if I worked out the value of 1 pen, I'd have to do 82 divided by 6 using the unitary method. So 82 divided by 6 tells me that 1 pen, oh, that's not a nice number, is 13 13.6 recurring. So we're just going to go with it. Then you've got a pencil. So let's work out how much 1 pencil is. Well, if I know that 15 pencils are 45 pence, 1 pencil is going to be, I'm going to have to divide by 15. So 45 divided by 15 tells me that 1 pencil is worth 3 pence. Then I've got rulers. So rulers are 10 for £1.25. So therefore 1 ruler is going to cost £1.25 divided by 10, which is just 12.5 pence. It will tell you on your calculator 0.125, but convert it back into pence. So 12.5 pence, and to convert a pound to pence, we times by 100. And then pencil cases are 37 pence each. So I need to work out the cost of 30 of these. So I'm just going to times each thing by 30. So 13.6 recurring times by 30 gives me 410 pence. 3 times 30 is 90 pence. I said rulers are, it should have been 1.25. I don't know why that 5. Oh, 12.5 pence. So 12.5 times by 30 is 375p, and 37 times 30 is 1,110 pence. So it's really good to consistently work in either pence or pounds, because if you mix them up, then sometimes things get muddled up. So now I know how much 30 of each costs. To work out the total is always where you just add all the values together. I'm just going to add all of this together. So 1,110 plus 375 plus 90 plus 410 gives me 1,985 pence. To turn it back into pounds, I'm going to divide by 100. So that's £19.85. Okay, so in this question, I'm told that Emily drives 186 miles in 3 hours, and I need to work out what her average speed is. So the formula that we should know is that speed equals distance over time. And if you ever forget this, then there's a quick way to remember it. So think to yourself, what is the national speed limit? It's 70 miles per hour. What does the 70 represent? It represents speed. What does miles represent? It represents distance. Per means divided by or out of, and hour is time. So speed equals distance divided by time. If you struggle to remember that formula. So to work out her average speed, I'm just going to substitute the values into the formula. So her speed is going to be 186, which is the distance, divided by 3. And 186 divided by 3 gives you 62. So her average speed is 62 miles per hour. Next, I'm told that Sarah drives at an average speed of 58 miles per hour for 4 hours. And how many miles does Sarah drive? So once again, looking at the formula, I know that speed equals distance divided by time. I need to work out how many miles she drives. Miles represents distance. So to rearrange that formula, I'd say that speed times by time equals distance. You might be using the little triangle that you have. So you cover up the you cover up the D, and then you know that speed times time gives you distance. So once again, what do? The speed is 58. The time is 4, and that's going to tell me what the distance is. So 58 times by 4 is 232 miles. Okay, next I'm told to write down all the prime numbers between 20 and 30. So you might intrinsically know these already. If you don't, then the best thing to do is to actually just write out all of the numbers. And then we can do something through process of elimination. So first of all, for something to be a prime number, it can only have 2 factors. So a helpful reminder, a prime number only has 2 factors, 1 and itself. And also 2 is the only even prime number. So therefore, any even numbers I can cross out immediately. So that's what I'm going to start by doing. And 2 is the only even prime number because it only has 2 factors, 1 times 2. Any other prime number, like for instance 4, I could say that's 1 times 4, but also 2 times 2. So it has 3 factors. And that's why any other even number is not going to be a prime number, because it's divisible by 2. So start by eliminating even numbers. Then we can try eliminating multiples of 3. So anything that is in the 3 times tables, so 21 is in the 3 times tables and 27. Then we can eliminate multiples of 5. So any number ending in 0 or 5 gets eliminated. Then we could try the multiples of 7, but I know that 7 would be 21, 28, 35, so it's not a multiple of 7. And if you try the multiples of 2, 3, 5 and 7, you essentially will have eliminated most of your prime numbers. So 23 and 29 are the only prime numbers between 20 and 30. Catherine says that 2 is the only even prime number. Is Catherine right? Yes, Catherine is right. Because 2 is the only even number that has only 2 factors. And a prime number can only have 2 factors. if you wanted to explain it in a little bit more depth, you could say every other even number would have 2 as an additional factor, e.g. 4 is 1 times 4, 2 times 2. So so it could not be prime. And the key thing here is to show your knowledge of what a prime number is. A prime number is a number that only has 2 factors, 1 and itself. And the only reason 2 is a prime number is because the only factors it has are 2 times 1. Okay, next we've got solving equations. So when I'm solving an equation, all I'm doing is I'm trying to get the variable, in this case x or y, to be on its own so that I can find out what its value is. So over here I've got x plus x plus x equals 51. I can simplify that. X plus x plus x gives me 3x. So 3x equals 51. And I can use a function machine to help me. So what's happening to x is being put into the machine, it's being multiplied by 3, and 51 comes out. And then I can work backwards. So 51 divided by 3 gives me, well, that's a calculator question. It'll be a decimal. So 51 divided, oh, it won't be a decimal, it's 17. So x is 17 because I've divided both sides by 3. So if you can see, what the function machine is doing is it's showing you what's happening with the algebra. The first part shows you what's happening, x is being times by 3, and then to figure out what x is doing, you do the reverse operation. And that's exactly what you do with the balancing method as well. So for the next question, y is being divided by 4 and I come out with 3. So as a function machine, what would I do? I'd write y is being divided by 4 and the output is 3. So then I need to work backwards to find out what's happening. The inverse of dividing by 4 is timesing by 4, and 3 times 4 is 12. So I would end up with y equals 12. The next one is a little bit trickier. So what's happening to the f? It's being times by 2. I then add 7 and 18 comes out. So this reverse inverse function machine is going to tell me what I need to do. The inverse of adding 7 is taking away 7. So I know I subtract 7 from both sides and I'm left with 2f is 11. Once I've subtracted 7, I'm going to have to divide by 2, and 11 divided by 2 gives me 5.5. Okay, next we have to draw an accurate pie chart. So to draw a pie chart, there's one really key piece of information that we just need to know, and that is the angles in a pie chart add to 360 degrees, and that's because a pie chart is also a circle, and angles in a circle sum to 360. So what I always do to figure out how much one person or one thing is going to be on the pie chart, I do 360 divided by the total frequency. So frequency just means the amount, and in this case, I'm told that a group of football fans were asked what their half-time snack was, and that the table gives me their answers. So I want to work out how many fans were asked in total. So I do 11 plus 17 plus 8 gives me 36. So I know that 36 fans were asked in total, and I want to split this pie chart into equal amounts for each fan. So if I did 360 divided by 36, 360 divided by 36 gives me 10. So I know that one fan is going to take up 10 degrees. So one fan is 10 degrees. And if I know that, then I can figure out how much space each sector is going to take. So for the burgers, there's 11 fans. I know that one fan takes up 10 degrees, so 11 times 10 is 110 degrees. For a pie, it's 17 times 10, so that's going to be 170 degrees. And for a hot dog, it's 8 times 10, so that's going to be 80 degrees. So Next, I get my protractor, I line it up exactly equally, and then I draw the pie chart. So 170 degrees might be the first one that I draw. I need to label it. So I'm going to write that's 170 degrees, and that is for the pie half-time snack. Then I could do 80 degrees, which is going to be a hot dog. And the final part is going to be 110 degrees, which is a burger. So always make sure that you're lining, if you end up with any space on your pie chart, then you know you've done something wrong, because with a pie chart, everything should match up and everything should add up to 360. So if you end up with a gap, redo your working, check that all of your angles add up to 360, and then just redo it. And that's a big warning sign to tell you to double check. Okay, so in this question, I'm told that a scout group has a raffle to raise money for charity, and that there is one prize to be won in the raffle. So lots of people are going to enter, only one person can win. Laura buys 12 of the raffle tickets, and a total of 350 raffle tickets are sold. I need to find the probability that Laura does not win the prize. Now, whenever you see something that is underlined in bold, it's because it's important, and because people frequently make a mistake here. So it's important that I'm working out the probability that she does not win the prize. So when I'm working out probability of an event, the denominator, I write it as a fraction, and the denominator is always the total. And the numerator is like your chance of that happening. So in this case, Laura buys 12 raffle tickets out of a total of 350. So the probability of her winning is going to be 12 out of 350. Now, probability, the chance of something happening and something not happening, must always add to 1. So this is a calculator paper. You could just do 1 takeaway, 12 over 350. And if you type that into your calculator, you'd end up with 169 over 175, which would be fine. So 169 over 175, it's been simplified. Or what you could do is, you know that there are 350 raffle tickets in total. Laura is going to have taken 12 of them. So if you do 350 take away 12, that's going to give you 338 over 350. And that's just a probability that makes more sense because it's dealing with what's actually been told to you in the question. So to work out the probability of something not happening, you do 1 take away the probability of it happening. Okay, next we've got a frequency tree. So I'm told that each worker in a factory is either left-handed or right-handed. And with a frequency tree, the key thing that you need to know is that this is going to add up to both of these, okay? So first I start off by filling in what information I've got. I'm told that 22 of the 45 workers are male. So I know that 22 of the workers are male. I know that these two little sections are going to have to add up to make 45. So what I could do is I do 45 take away 22, and that leaves me with 23. So I now know that there are 23 females. Again, the same thing happens. These two branches are going to have to add up to make 22, and these two branches here are going to have to add up to make 23. So I can fill in the information I've been given. It says 16 of the 34 right-handed workers are female. So I know that right-handed workers must add to make 34. And I know that 16 of them are female. So if I did 34 take away 16, that leaves me with 18. And now I've got the information that I need, because I know that these two branches must add up to 22. So 22 take away 18 is 4, and 23 take away 16 leaves me with 7. So hopefully you can see that each time, well, I don't know what the actual word is for it, but this sums to 45. Like if you think of it as a column, this will sum to 45 and this part here will sum to 45. So it's just a way of separating your information into smaller and smaller subsections. Okay, next we've got a bit of angle reasoning. So Mary needs to work out the size of angle X in this diagram, and she says that X is 63 degrees because base angles of an isosceles triangle are equal. Mary is wrong. Explain why. Essentially, her reasoning is right, except she's applied it to the wrong thing. So normally, you're shown an isosceles triangle like this, and you're told the base angles are over here. But the base angles are essentially wherever your two equal sides are, the angle that's trapped in between that, so in this case X, that's not a base angle. The other angles are. So this would be the base angle. So Mary is wrong because X is not a base angle. Angle BAC would be the base angle. So if we turned that around, this is what it would look like. So C would be at the top, A over here, B, and that would be 63. And this would be your base angle here, and that would be X. It's basically the triangle, it's just been turned over. Okay, next I'm told that William needs to work out the size of angle Y in this diagram. I know that I've been given parallel lines. So what I can do first of all is just extend this just to make my life a little bit simpler. It might help, it might not, but it helps show the transversal, which is the diagonal over here. Just might make things a little bit easier. So William writes angle EGH. So angle EGH would be this angle here. It's 57 degrees because corresponding angles are equal. Well, that's wrong because this angle and this angle here are alternate angles. So when they're on alternate sides of the diagonal, that's when we call them alternate angles. So we'd say angle EGH is 57 degrees because alternate angles are equal. The corresponding angle that he's talking about, if I wanted to have a corresponding angle, it would be over here. So it's important to know your different angle rules. His other reason is Y is 180 takeaway because angles on a straight line add up to 180 degrees. So that one's also not amazing. It should have been co-interior angles, sum to 180 degrees, but that one might be forgiven because perhaps he worked out that this is 57 degrees. But yeah, the main one is this is definitely not a corresponding angle. Okay, Marla buys some bags of buttons. There are 19 buttons or 20 or 21 or 22 buttons in each bag. The table gives some information about the number of buttons in each bag. And I know that the total number of buttons is 320 and I need to complete the table. So what a frequency table is telling me how many lots of each thing there is. So for instance, I know that there is one lot of 22 buttons. So in total, there's 22 buttons. I know that 3 bags have 21 buttons in them each. So if 3 bags have 21 buttons in them each, I'm going to need to do 3 times 21, which is 63. I know 7 bags have 20 buttons in them each. So I'm going to have to do 7 times 20, which is 140. And I know that in total, there's 320. So if I add the buttons that I know about together, so I've got 140 plus 63 plus 22, which is 225. I know that this missing part here must be 320 take away 225. What's left over? So I've got 95 buttons left over. So 19 times by something is going to give me 95. So if I did 95 divided by 19, that gives me 5. So I need 5 buttons, 5 bags that have 19 buttons in them each to make 95. So the key with a frequency table is understanding that it's talking about how many bags there are. So putting the question into context of the table. So 5 bags have 19 buttons in them each, 7 bags have 20, 3 bags have 21, and 1 bag has 22 buttons in them each. So the total amount of buttons is like this extra column that we could have. But that's how we'd work out a frequency table. Next, we've got an ingredient list. So here's the list of ingredients for making 30 biscuits. I'm told that Lucas has the following ingredients, and I need to figure out what the greatest number of biscuits Lucas can make is. Again, there are lots of ways that we can do this. But seeming as it's a calculator paper, perhaps the easiest way is to work out how much 1 biscuit is. So for butter, to work out how much 1 biscuit is, I'd need to do, I know that 225 grams makes 30 biscuits. So to work out what 1 biscuit would be, I'd have to do 225 divided by 30. So each time you're working out how much 1 unit cost is, you just divide by how many of the thing you have. So in this case, I've got 30 biscuits. To figure out how much 1 biscuit would be, I'd divide each ingredient by 30 to find 1 biscuit. So for butter, I'm going to need 7.5 grams for 1 biscuit. Sugar, I'm going to do 110 divided by 30, which is 3.6 recurring grams. Not a great number. Flour, I'm going to do 275 divided by 30, which is 9.16 recurring. So just a little tip, sometimes in your calculator you're going to get a number like this where it says 9.16 and then it goes 66666 and at the end 7. That essentially means that it's a recurring number. So you can just write the recurring to make your number more accurate. And then we've got chocolate chips. I'm going to do 75 divided by 30, which is 2.5 grams. So this is how much you need for 1 biscuit. So then I know I've got 900 grams of butter, so I could figure out how many biscuits I could make using my butter. So I'm going to do, for butter, I'll do 900 divided by 7.5. So 900 divided by 7.5 is 120. So I can make 120 biscuits using that butter. Now I'm going to try the sugar. So I've got 1000 grams of sugar and I can divide that by 3.6 recurring. So 1000 divided by 3. And if you don't know how to do a recurring, I can't actually find it on this calculator. Well, if you can't find recurring, just type in 66666 like loads, and then it will automatically turn it into a recurring thing for you. So that's 3000 over 11, which is 272.72 recurring. So essentially 272 biscuits, because we can't have point something of a biscuit. Then we've got flour. So 1000 divided by 9.16 recurring. So 1000 divided by 9.16, recurring is going to give me 109.09, and that again I would round to 109 because we can't have point something of a biscuit. And for the last one, I've got 225 grams of chocolate chips, so I'd do 225 divided by 2.5. 225 divided by 2.5 is 90. So using all of these ingredients, even though he has enough sugar for 272 biscuits and enough butter for 120, he only has enough chocolate chips to make 90 biscuits. So therefore the greatest number of biscuits he can make is 90 biscuits, because you're always gonna, whenever you're making something, if you don't have enough of one ingredient, you just can't make the thing. Otherwise it's gonna just be something else. It won't be following the recipe. So yeah, the greatest number of biscuits he can make is 90 biscuits. Okay, so in this question, I'm being asked to describe fully the single transformation that maps shape A onto shape B. So common mistakes people make is that they write more than one transformation, and also they accidentally start from shape B. So single transformation means it's either going to be a reflection, a translation, or a rotation. Now, because the shape is in the same position, it's just switched over, it's going to be a reflection. It can't be a translation, because if it's a translation, it's moved, and so therefore it has to look exactly the same. And a rotation also is going to change the way the shape is facing. So it's a reflection. And when you say, it's asking you to describe the transformation fully, so you'd say it's a reflection, and then we need to find the line of reflection. So let's look at the distance between the 2 points. So we've got 1, 2, 3, 4, 5, 6. So the line of reflection, or the line of symmetry, is the halfway point. So halfway between these 2 points is 3 coordinates across. So that must mean it's a reflection in the line. Now there's a few ways we can call this. So you could call it the y-axis, or you could call it the line x equals 0, because if we're talking about lines of reflection, this line is when all of the x coordinates are always going to be 0. So that's 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. So just saying it's a reflection in the line what x equals 0, or a reflection in the y-axis. Both are the exact same thing. The y-axis is when the x coordinate is 0. So yeah, for reflection, look for the halfway point, and that's how we do that. Next, I am being told that a farmer has a field in the shape of a semicircle. So a semicircle is half a circle, and its diameter is 50 meters. The farmer asks Jim to build a fence around the edge of the field. Okay, so the edge of the field is going to be this plus this. So whenever you're having a question where it's maths in context, actually think about the context. If they're going to fence something in, it has to go around the perimeter, around the outside. So Jim takes 3 days to build the fence. Work out the total cost. Okay, so first of all, I'm going to need to work out what the distance of the fence is going to be. So how do I work that out? I'm going to need to find out what the circumference, or what the perimeter of this half circle is. So to work out the circumference of a normal circle, I do pi times by the diameter. But because this is half a circle, what I would do is pi times the diameter and then half it, which is the same as dividing by 2. So the diameter is a line from one side of the circle to the other, and pi times the diameter would be pi times 50, and then I'd have to divide it by 2. So I can type this into my calculator. or you might be familiar with pi already and know that 50 pi divided by 2 is going to give you 25 pi. But either way, let's type it into our calculator because we need to figure out what 25 pi is. So you can type just pi times 50. So pi times by 50, like that. You have to press the shift button and then you find where pi is on your calculator. So shift pi times by 50 and then divide it by 2 because it's half a circle is 78.5398164 plus 50, because I've worked out this bit here by working out the circumference, just the circular bit, but then I need to add on this bit as well. So that's going to give me a total distance of 128.5398163 meters. So now that I know the total distance of the fence, I can think about applying it into the formula. So the fence is 128 point, let's round it to 54 meters. And I know using the formula, the total cost is going to be £29.86 per meter. So I'm going to times that by 128.54, because for 1 meter it's going to cost £29.86. For 128.54 meters, I'm going to need to times 29.86. So that's going to be the cost of the fence plus £180 for each day's work. And it says Jim takes 3 days to build the fence, so it's going to be 180 times by 3. So I do these separately. So that gives me 29.86 times by 128.54 is 3,838.2044 plus, and then I've got 180 times by 3, 540. So if I add that together, I end up with £4,378 21. It doesn't matter what you round it to, as long as it's you've given a reason. I'm going to write 21 because with money generally people round it up, but as long as you got in the region of 4,378.2 something, that's absolutely fine. Generally it's best not to round anything up until the very end. I rounded over here. Ideally, if you don't round, then you're going to get the most accurate answer. Okay, next we've got simplifying indices. So we just need to know a few of the rules. So when you're multiplying indices, so like if you've got 2 to the power of 5 times 2 to the power of 7, what do? You add the indices together. So that's called the law of multiplication. So over here, if indices aren't your strong point and you don't feel confident with the adding, you could just actually take it back to its basics. So what does m to the power of 3 mean? It means m times m times m. And m times to the power of 4 means m times m times m times m. So how many times in total have you multiplied m by itself? 1, 2, 3, 4, 5, 6, 7. And that's why we say we add the indices together, because repeated multiplication is the same as addition. But whichever way you get there, that's absolutely fine. Now the next question is a little bit trickier. So ideally you're going to know your laws of brackets. So the laws of brackets is that anything, when you've got indices, like let's say you've got a to the power of 5 to the power of 3, you multiply the powers. So that would become a to the power of 5 times 3. And that applies to each thing inside the bracket. So we'd have to do 5 cubed n cubed and p to the power of 3 cubed. So that would become 5 cubed, n cubed, and then p to the power of 3 times 3 is 9. And because it's a non-calculator paper, they'd expect you to simplify 5 cubed into 125, n cubed p to the power of 9. Now this is quite a tricky one, so I'm just going to go through how we could do it a bit differently. So what does cubed mean? Cubed means multiplied by itself 3 times. So I could write this out, 5 times n times p cubed 3 times, okay? So that might help me to see what's happening a little bit clearer. So then you're like, oh, okay, so I do 5 times 5 times 5, which is 125. I'm going to do n times n times n, which is n cubed. And then I've got p cubed times p cubed times p cubed, which is going to give me p to the power of 9. So sometimes writing out the algebra and doing it the slightly longer way can be helpful. Okay, so next we've got a division question. So we need to know the laws of division. So when you've got an indice, let's say you've got a to the power of 10 divided by a to the power of 5, we subtract the powers. So when we're dividing indices, we subtract the powers. So we'll do the quick way first and then the different way. So we do 32 divided by 4, which is 8. Q to the 9, so q to the 9 divided by q to the 3 is going to give me q to the power of 6. And then you've got r to the power of 4 divided by r. And remember there's an invisible 1 over there, so that would be r to the power of 3. So that's the quick way if you're feeling confident with those. If not, then we can take it back to its basics and just write it out. So what does q to the power of 9 mean? It means 1, 2, 3, 4, 5, 6, 7, 8, 9, and then times by 1, 2, 3, 4. And that's being divided by 4 times by q to the power of 3 times by r. So what we can do, we still do 32 divided by 4. So 32 divided by 4 is 8. And then anything that you've got on the top that's the same as anything on the denominator, you can just cancel out. Because if you did 5 divided by 5, that's 1. So therefore q divided by q is also going to be 1. So q divided by q is 1, q divided by q is 1, q divided by q cancels out. And then I've got an r over here, so r divided by r. So I've cancelled out everything on the bottom. And then on the top, I've done 32 divided by 4 is 8. I'm left with q. I've got 1, 2, 3, 4, 5, 6, q to the power of 6, and then r to the power of 3. So that's the why of when we're dividing indices. You choose whichever way is best for you. Okay, so in this question, I'm being asked to find the lowest common multiple of 40 and 56. And now there's a few ways of doing it. I could start out by writing out the 40 times tables and the 56 times tables and finding the first number that is common in both of those. Or a slightly quicker way is by using the prime factor and Venn diagram way. So the way to do that is to set up my numbers and then think of 2 numbers that multiply to make it. So for 40, I think of 2 times 20. When I reach a prime number, I circle it and I continue with the other branch. So to make 20, I do 2 times 10. I've got a 2 over here, so I'm going to circle that. And then to make 10, that's 2 times by 5. So now I have written 40 as a product of its prime factors. So I know that 40 is equal to 2 times 2 times 2 times 5. I can double check that. 2 times 2 is 4, times 2 is 8, times 5 is 40. So now I do the same for 56. So I'm splitting it up. Generally, it's best to start with 2. Try dividing your number by 2, 3, 5, 7, essentially the prime numbers. It makes your life a lot easier. So 2 times by, and it's been a long day, so I'm just going to use a calculator. 56 divided by 2 is 28. So 2 times by 28, I circle the 2. And then I've got 2 times by 14 makes 28. Again, I circle the 2. Then I've got 2 times by 7, circle the 2, and 7 is also a prime number. So I know that 56 is equal to 2 times by 2 times by 2 times by 7. Now I get my Venn diagram, so I just draw 2 circles that are overlapping. This one's going to represent the factors of 40, and this one represents the factors of 56. And what goes in the middle is anything that they have in common. So I can see that 2 is in common, so I write that once. There's another 2 that is in common, so I write that once, and another 2, so I write that once. And then for the factors of 40, there's a 5 left over, and for the factors of 56, there's a 7 left over. Now, to work out the lowest common multiple using this method, I multiply everything inside the Venn diagram. Okay, so the lowest common multiple, I multiply everything. So 2 times 2 times 2 times 5 times 7 would give me 2 times 2 times 2 times 5 times 7 is 280. So the lowest common multiple of 40 and 56 is 280. In the second part of the question, I don't know what the number is, but they've told me what it is in its prime factorisation. So A is 2 times 2 times 2 times 3 times 5, and B is 2 times 2 times 3 times 5 times 5. I've just expanded 2 cubed to be 2 times 2 times 2, and 2 squared is 2 times 2, 5 squared is 5 times 5. So I do the same. I draw out my Venn diagram, and I've got the factors of A and the factors of B. So 2 is a common factor, so it goes in the middle. 2 again, and I only write it once because it's common to both. Then I've got 3 that is common to both, and then I've got a 5 that is common to both. Then there's a 2 left over here and a 5 left over there. Now the highest common factor is where you multiply the middle part, the crossover, the intersection. So for the highest common factor, when we're using a Venn diagram, we're just going to multiply everything in here. So it's going to be 2 times 2 times 3 times 5. And 2 times 2 times 3 times 5 is 60. So when we use the Venn diagram method, just a quick recap, you split everything up, and to get the lowest common multiple, you multiply everything in the Venn diagram. To work out the highest common factor, you just multiply everything in the intersection, in the middle bit, in the crossover. Okay, now I'm being asked to work out what the equation is for line L. So every single straight line needs to be written in the equation y equals mx plus c, where m represents the gradient and c represents the y-intercept. And the y-intercept is the easiest thing to find because the y-intercept is literally where the line crosses the y-axis. So the y-intercept over here I know is 6. So I can rewrite that equation as y equals mx plus 6 because I figured out that that's what the y-intercept is. The next thing I need to do is work out the gradient. And to find the gradient of any line, it's the change in the y coordinates divided by the change in the x coordinates. And what that means in theory is that you can draw a triangle. So find a part where the line crosses through exactly the diagonal of a square and just draw yourself a triangle. So I've chosen this. I could also have made the triangle shorter and done this, but it doesn't matter because it's all going to be in the same ratio. So what I do is I work out the change in y. So the gradient is basically the vertical distance divided by the horizontal. So the change in y is from 0 to 6 is 6, and the change in x is 2. So therefore the gradient is going to be 6 divided by 2, which is 3. Therefore, my line is going to be y equals 3x, 3 is the gradient, plus, oh, and actually, I wasn't paying attention, this is minus 6. So the line crosses the axes at -6, So I just rewrite that as y equals 3x minus 6. So yes, always pay attention to where the coordinate is. Okay, next I've got a money question. So I'm told that Raya buys a van for £8,500 plus a VAT. VAT stands for value added tax. Sometimes, like when you go to a big supermarket, they include VAT in the price, so you don't have to add anything. But when you're buying big purchases, they don't include that in the price. So VAT means what you have to pay on top of the purchase price. So the van is £8,500, and separately you need to add on 20% for VAT. So 10% would be 850, and therefore 20% would be, I'll just double that, 850 times 2 is 1,700. So the first step might be to just work out what the cost of the VAT is. Again, if you wanted to do it on the calculator, we could have just done 8,500 times by 0.2, because 20% means 20 over 100, 20 divided by 100, this line means divide, is 0.2. So to work out 20% using a calculator, I can use the multiplier method. So I'm told that she pays a deposit for the van. She then pays the rest of the cost. So the rest of the cost means this plus the VAT, in 12 equal payments of £531 each month. Find the ratio of the deposit Raya pays to the total of the 12 equal payments. So first of all, what's the total cost of her van? So 8,500 plus 1,700 is 10,200. So that's the cost of the van. So let's just put that somewhere. So 10,200. And then I know she pays 12 equal payments of £531. So that's 12 times by 531.25. So 12 times 531.25 is 6,375. So that's how much she pays after she's paid the deposit. To work out how much the deposit is, I'm going to need to do 10,200, which is the total cost, take away the equal monthly payments, which gives me 10,200, take away answer is 3,825. So the deposit is this, and the monthly payments is, or the total of the monthly payments is this. So I've got 3,825 to 6,375, and I need to give my answer in its simplest form. So I could start by dividing by 5 on both sides. So that would give me 765, and 6,375 divided by 5 is 1,275. I could divide by 5 again. So this is with a calculator, so makes life a lot easier. Divide by 5 again, and 765 divided by 5 is 153. So now let's see how I can further simplify it. So I've got to 153 to 255. I can't divide by 5 because 3 is not in the 5 times tables. So I could try dividing by 3 and see if that works, and it does. So that would be 51, 255 divided by 3 to 85. This looks like we might not be able to get any further. When you're simplifying, and just when you're dividing in general, it's always best to use the prime numbers because you just get there a lot quicker. So let's try 3 again. So 51 divided by 3 is 17. 85 divided by 3 doesn't work, so I can't divide by 3. I can't divide by 5. Let's try 7. So 51 divided by 7 is not going to work. 11's not going to work. So that's the simplest I can make it. So 51 to 85. Okay, so this is a very sneaky question because it's got a nasty division. The last part, so I tried 2, 3, 5, 7, 11, 13. But actually, we needed to divide by 17. So it's a calculator paper, so I guess it's fair in that you just keep on going. So 51 divided by 17 is 3. And 85 divided by 17 is 5. But if you only got to 51 out of 85, you still would have got 4 marks, just not got to the final part. And I'm just going to show you another way that you can simplify ratios if they're a little bit trickier. So now I've forgotten what the total amounts are. So it was 3825 to 6375. So what I can do, and I'll just show you how you do it with an easier one. So let's say 2 to 3. So if I did, no, that doesn't make sense because 2 to 3 is already simplified. Let's say I did 15 to 45. So if I typed into my calculator 15 divided by 45, 15 over 45 as a fraction would simplify to 1/3. So the way you could do it is turn it into a fraction, and then obviously 1/3 to write it as a ratio would be 1 to 3. So 15 you've divided by 15, and 45 you've divided by 15, and it gets you to 1 to 3. So similarly, you could do 3825 over 6375 and type that into your calculator. 3825 divided by 6375 gives you 3/5. So then you would know that your ratio is 3 to 5. But normally, like 9.999 times out of 10, just a simplifying method will be absolutely fine. Okay, next I've got a table of values. So when you've got a table of values, what it means is you're given your x coordinates and you're given an equation. In this case, y equals x squared minus x minus 6. So what you do is you start by substituting the x values. The best thing to do is start from the right hand side, just because it's easier with positive numbers and it might give you a bit of confidence. So for the first one, x is 3. So I'm going to do y equals 3 squared minus 3 minus 6. So what does 3 squared? That's 9. Take away 3, take away 6. And 9 take away 3 is 6. 6 take away 6 is 0. So that's what I do for the first one. I do the same thing for the second one. So I'm going to substitute x is 2 into this equation. So y equals 2 squared, take away 2, take away 6. So you can also do this on your calculator, but I'm just showing you what it would be. So that would be the same as 4 take away 8, which is minus 4. Then for the next part, we've got y is 1 squared, take away 1, take away 6. So y is 1 take away 7, which is negative 6. Then it gets a little bit trickier with your negative numbers, and it's very important to remember when you're multiplying a negative by a negative, it gives you a positive result. So like negative 5 times negative 5 is positive 25. Any negative number times by its any other negative number is a positive answer. So I've got y equals minus 1 squared minus minus 1 minus 6. So minus 1 squared is going to be 1. When I've got two negatives next to each other, it becomes a plus. So that becomes y equals 2 minus 6, which is negative 4. And for the last one, I've got y equals minus 2 squared, take away negative 2, take away 6. So the tricky bit here is that I'm subtracting the value of x, and when you're subtracting a negative, it's actually the same as adding. So y equals minus 4 plus 2 minus 6. So that's the same as saying minus 10 plus 2, which is it? Minus 4 plus 2 is minus, I might have done something. Oh, sorry. It's not a negative 4 because any negative number times by itself is positive. That was supposed to be an equal sign. So 4 plus 2 is 6. 6 take away 6 is 0. So that's how you do your table of values for a quadratic. The best thing, you can use a calculator, but if you're not confident with what it should be, just break the algebra down and substitute your value into it. And then, so I've got 0, negative 4, minus 6, minus 4 and 0. Then you plot it. Now, if you see a y equals x squared something, that means it's a quadratic. So your graph is going to look like this. It's going to be curved. Okay, so now that we know that it's a quadratic, all we do is we plot the coordinates. So the x coordinates go along the x-axis, we go along the corridor, and then we use the y-axis to go up the stairs or down. So first I've got minus 3, 6. So I go along to minus 3 and up to 6, and I put a little cross. Then I go minus 2, 0. So I put a cross there. Then negative 1, negative 4. I put a cross there. 0, minus 6. 1, minus 6. 2, minus 4. And 3, 0. So whenever I've got a quadratic, I know that it's going to look roughly like this. And then the really important thing is that I connect all the dots using freehand. So not a ruler, I'm not connecting it with straight lines, I'm just connecting them, and I'm going to make a little curve. So that is what my quadratic should look like. And then it's saying use your graph to find estimates of the solutions to the equation x squared minus x minus 6 equals minus 2. So this is the graph of y equals x squared minus x minus 6, and I want it to find the solutions for when the graph equals minus 2. So what I do is I draw the line y equals minus 2, which would be over here. So now what I do is I look for the solutions. So over here is where, when you've got solutions of an equation, so using graph, solutions is where, if it's two lines, it's where the lines cross, or if it's a quadratic, it's where the graph and the straight line crosses. So I draw the line of y equals minus 2, and then I just look for the solutions. Now my graph is quite blotted, but I'd say that's probably minus 1.6. So it would be when x is minus 1.6, and then over here that looks like 2 So what I did is I read this coordinate there where it crosses, and this coordinate here, which looks like 2.6. So that is what my solutions would be. So whenever you're finding estimates of a solution from a graph, just draw a straight line. In this case, you want it to be, it said minus 2. So I draw the line y equals minus 2, and then just say where the graph meets the straight line. Next, I've got a pressure, force and area question, and they've provided the formula for you. So I'm told that a force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons, and the area is increased by 10 centimeters squared. Helen then says the pressure decreases by less than 20%, and I need to say if Helen is correct or not. So first what I can do is actually work out what the pressure is. So pressure is force divided by area, like the formula tells us here. So the force is 70 and the area is 20. So if I just type that into a calculator, 70 divided by 20 is 3.5. So that would be 3.5 Newton. And the way you know what the pressure is the force is given to us in newtons. So I know that's newtons over, and the area is in centimetres squared. So it would be 3.5 newtons per centimetre squared. Now the new pressure, it says the force is increased by 10 newtons, so that would make it 80. And the area is increased by 10 centimetres squared, so that would make the area 30. So if I did 80 divided by 30, that would give me 2.6 recurring newtons per centimetre squared. So it says the pressure decreases by less than 20%. So what I could do is figure out what 20% of 3.5 is. So 3.5, or if I wanted to, I could either work out 20% and subtract it, or just use a multiplier. So if I times it by 0.8, effectively what I've done is 100%, take away 20%, which is 80%, which is what I'm trying to find. So multiplying by 0.8 is finding 80% of the original. So 3.5 times by 0.8 is 2.8. So a 20% decrease would mean the pressure is 2.8 newtons, but it's 2.6, so Helen is wrong. So we've worked out essentially what the pressure was originally, which is 3.5, and then we worked out what the new pressure would be, but it's actually more than a 20% decrease. So Helen is wrong. If I wanted to work out what it would be as a percentage, I could have done 2.6 recurring divided by 3.5 times by 100, and that would tell me that 2.6 is 76.2% of 3.5, so Helen is wrong. So there's two ways I could have done that. And this relies on your knowledge of percentages. So if you're not 100% on that, then recap on multipliers and how to figure out percentages of an amount. And then lastly, I need to work out the volume of a prism. Now, to work out the volume of any prism, whatever the shape is at the front, you can just work out the area of the front face and times it by the length. So that is the formula for any prism, and a prism is just a 3D solid that has a constant cross section. So it's like a Colin the Caterpillar birthday cake that has, however you slice it, it's going to give you the same shape. An ice cream cone is not a prism because it gets smaller and smaller and smaller. So a prism is if it's the same shape throughout. If you like pushed that shape throughout the shape, it would remain the same. And the face is the front, well, any of the outside bits would be a face, but we do the area of the front face times by the length. So that means I know that I need to work out the area of this triangle. Now, how do I work out the area of a triangle? I have to do base times by perpendicular height divided by 2. And this is where a lot of people are going to get caught out because they might use the slant height, which is the diagonal height. But when I'm working out the area of a triangle, I need the base and the height to be perpendicular, which means at right angles too. So that means I need to figure out what this is here. So I've got a triangle. I know what this side is. I know what this side is. And I need to figure out this missing side. So when you've got a triangle and you know two sides and you need the third side, you use Pythagoras. So Pythagoras' theorem states that a squared plus b squared equals c squared, and c is the longest length. So I know that this is going to be c. It doesn't matter whether this is a or b, it's the two shorter sides. So when you've got the longest side, you actually, in order to get this, we're going to have to subtract b squared. So we could rearrange it to say c squared minus b squared equals a squared. And in this case, c is going to be 8.4. So I do 8.4 squared, take away let's just switch these around actually, because otherwise that doesn't make sense. Like I said, it doesn't matter which one's which. So 8.4 squared, take away 7.2 squared is going to give me a squared. So if I type that into a calculator, 8.4 squared, take a 7.2 squared, gives me 18.72. So I know that a squared is 18.72. And how do I get a? I have to do the inverse, which is square rooting. So I type the square root of 18.72, which is 4.32661531. So I know now that this side is 4.32. Now, what I need to do is work out the area of the front face. So how do I work out the area of a triangle? Like we said before, it's base, which is 4.32. And I can just save that in my calculator. I don't touch my calculator. And then I don't need to write everything out. So I'm going to do base times by height, 7.2, divided by 2. So 4.362 I leave on my calculator. I times it by 7.2. And then I divide by 2. So I know the area is 15.57598151. And that's the area of the front of the prism. Now, what I do once I work out the area, I multiply the area by the length. So I'm just going to do 15.57 times by 18. And if I've left it in my calculator, I don't need to write it all out again. I just multiply by 18, and that gives me an area of 280, or volume, sorry, 0.3676672. And it says, give your answer correct to 3 significant figures. So 1, 2, 3. This is the third significant figure. I look next door. 3 is less than 4, so I know I'm rounding down. So that would be 280, and it's going to be centimeters cubed because it's a volume. Okay, and that's it for this paper. So hopefully that was helpful. If you need more explanation on any topic in particular, just leave a comment and I can make a separate video on that specific topic.